Okay, and we move on to the last question for the tutorial, question 12 of the MCQ. So in this case, this is what I call a pattern recognition question. So there are reactions that you have not learned before, so you have never seen NaIO4 over here. But if we were to look at the context for it, they say that it is basically oxidizing a vicinal diol. Now, if you do not know the words, it doesn't really matter. It will usually give you a context of an equation. Now, you can see clearly that this compound here, the diol, which bond is broken? This particular bond is broken. Why? If I do some color coding for you to see, CH3CH, the OH now becomes an aldehyde because you break the carbon-carbon bond. The other fragment here, CH3, OH, H, again you get CH3, CH, together with a double bond O. So you can see from the alcohol, it now becomes a carbonyl compound, aldehyde in this case. So the question now wants you to extend this pattern recognition into compound M. Now compound M, clearly you can see there are two alkenes over here. Now the question that you have is, what has the alkene got to do with the diol? What is the relevance? But you notice that it is first treated with co-alkaline equals K-4. This is your mild oxidation. So quick recap of what we learned from alkenes. Your CC double bond upon K-4 alkaline co will become a diol. So basically, first of all, we must first draw what's the oxidized product of M before we can consider NaIO4. Alright, so let's take a look. Alright, so we have our alkene here. Basically, with alkaline K-4, what happens is that this double bond will be gone. What we're going to do is going to add an OH here, add an OH here. Similarly, we're going to oxidize and add an OH on this carbon, add an OH on this carbon. And this is how I get the structure of the product from co-alkaline K-4. Okay, so if we were to repeat the observation that we see earlier on, we basically break the CC bond in between the two carbons with the OH, and then we get our aldehyde respectively. I'm going to repeat the same thing that I do over here. Break this bond and break this bond. So these two bonds here will be broken. Okay, so if I were to break these two bonds, how many fragments will I get? I'll get my fragment 1, highlighted in yellow. Fragment 2, highlighted in green. And last but not least, the last fragment. So for the fragment yellow, basically this carbon, after breaking this bond, it will form an carbonyl compound over here. So let's take a look. That's the first fragment. You have a CO double bond. Alright. And then, for the green fragment, again, this particular carbon I'm circling now in red will form a carbonyl compound, C double bond O. Same thing for this, we also form a C double bond O. Alright, so C double bond O, CH3, CH2, C double bond O, and then H. Alright, so you can see. The last part, you're going to get a C double bond O here with an H and then CH2, CH3. And that's the orange fragment. Okay, so once you have the fragment, all you do is to systematically compare the options that you have over here, which one matches. So you have the yellow fragment, it's propanone, 3-carbon ketone. So these are the possible ones. For the second one, you have an aldehyde and a ketone. This looks like the only possible one out of the remaining 3. And last but not least, you have a CH3, CH2, CHO. And this is the last one. Oops. Let me change the color code. It should be a green color fragment. And then the orange color fragment. Of course, this structure is not drawn very accurately. It's supposed to read CH3, CH2. Alright, can? So in this case, answer will be therefore be D. Alright, answer will be D, because it matches the fragments that we have over here. Okay, with that, we are done with question 12.